Hello, this is Papa Alpha 3 Victor Oscar Sierra. Today I want to show you my latest project, which is a visual rotor. This is an antenna rotor controller based on Arduino Mega 2560 with a TFT shield which can be connected directly to the Mega 2560. What is so special about this? Well, this video is a kind of introduction, so I won't get into the details, but this controller is a controller which is capable to control 4 rotors, antenna rotors, regardless what brand or what type. They can control AC motor controlled antenna rotors, but also DC motors. So but it has a lot of very interesting features, like it supports LAN, it supports USB, it supports Android, and it supports also infrared remote control. Several things which might be very interesting to use the visual rotor also via the network and have it controlled by external software. The software is not for free. There is a small charge of 20 euros at this moment, but it also only counts for the version 1.3 at this moment. 1.4 is coming up, and we work already on 1.5. Although we don't know exactly if there will be a price increase on the 1.4 already, but it probably will mean a small price increase because of the lot of work which involved within it. So let's start it up. This is my originally my Daiwa DC7004 controller, which belongs to a Daiwa antenna rotor. I modified it. The touchscreen is here built in. I removed all the original hardware, the PCBs, because I think that the present solution with the visual rotor is much more interesting than the old Daiwa PCBs, which contains also a lot of components which are not available anymore. So let's switch it on. I have registered it on my call, of course, but you can see your call in the display if you register it on your call sign. It takes a few seconds to start up, which is quite normal.
2, 1, 3.
And you hear the direction of the antenna is already announced by visual rotor. As I said, it supports 4 rotors, so when you start up, you get the rotor in the screen where you, which you chose for the primary rotor to control. By the way, if you chose to use also an elevation rotor, you get 2 spheres in the screen next to each other, but this is something I will explain in later videos. I will show you very shortly. But okay, the first step, I show you that we have the choice of 4 rotors. In my case, I chose rotor 2 for the simple reason that for a software upgrade, you need to remove the TXD and the RXD on the Arduino board, which is not too convenient, of course, if you need to desolder them. But in the near future, that will certainly change, and you can leave the wires on the PCB and just do the update via the USB port of the Arduino. So back to the next screen. or the main screen actually. What you see here is the rotor clock. It's completely touchscreen, but it also has a encoder. You can see all the features, by the way, in my screen, which are activated. You see here the IP number from the rotor. I will explain that in a later video. The encoder is active here. I configure this as a AC motor because the motor in my rotor is a 26 volt AC rotor. And you see here the support of RS-232. In my case, I use the USB to serial interface, but you can also use a 9-pole connector, of course. Or interface. The baud rate, of course, LAN is active, but you see that already here by the fact that it got a IP number, and then R+5 means that I have a ramp up of 5 degrees. I will explain that also in a later video, but you can use a kind of soft start and soft stop functionality. It supports sounds. That means that it will announce your antenna direction when it reaches the destination, and I will show you that also here in the video, in the introduction video. I configured my visual rotor as azimuth rotor because I only own an azimuth rotor and don't do anything with elevation rotors. It's registered to my call sign. So this is the main screen. Let's see what's up. These are the buttons for the memories. Actually, it got 8 memory channels. You see here only 4 channels, but I can switch to the other channels, and now you see the other 4 channels here. You can program them independently. Put the direction of your rotor to your own requirements. So this is very clever that he did it. The P stands for parking. This is the position where the antenna can be parked when you would like to have the antenna in a certain direction, always pointing where mainly the wind comes from. For instance, you can park it into to the direction you want. Also, this one is free programmable by just touching the screen. It's you don't have to have any programming skills. The only thing that you need to do when you receive the license and you got already the Arduino Mega 2560 and the Shield, you have to upload the software, of course. That's very easily done by Xloader, which is a very simple program which helps you to upload the software. Right then, then you can make small steps, 1 degree up, down, and 1 degree up when you would like to do that. For instance, for SHF guys who like to move their dish antenna just 1 degree, which is sometimes very wishful. You can do that as well. Okay, well, that's what the main menu shows. Then we have here the menu button. The menu button shows you also a sub menu. In the first place, what you see now applies to the rotor you have selected, so you can independently configure all the rotors you have connected to Visual Rotor. You don't need any of the settings for the next rotor as well. So this is completely independently. First of all, I want to give the rotor a name. So you can give it a certain name. In my case it was a Daiwa, but if you have several rotors and you want to make sure that you're selecting the right rotor, you can give them a name. Of course you need to give them a type. Is it an azimuth or elevation rotor? And back again, you can define the colors of the screen if you would like to. Then we have the possibility to choose whether it is a normal one rotor, so only one rotor, so you can also see one sphere only. If you have two rotors, and that might be two azimuth rotors, then you have both clocks next to each other, and you have the possibility to choose azimuth and elevation. So you get the azimuth on the left side and the elevation on the right side. You can't change that. Why? It's just the way it was programmed by the author. But the elevation is of course only running from 0 to 90 degrees, I guess, but I haven't selected then, so I cannot tell you exactly. But never mind, this is also explained in the manual. By the way, the system supports multiple languages like English, German, Polish, Spanish, French, a couple of different languages. So, but you can see that in the manual as well. It will even support Dutch, and that is one of the things I added. Also with the languages, not only with the screen itself. Right then, back to the menu. Ramp and overlap is a way to, the ramp is only used for the AC motors, so you can make a soft stop and soft start. Overlap is for rotors, antenna rotors that have a certain overlap beyond the 360 degrees. So this is also a possibility to set in the settings. Then the mode, it gives you the possibility to control it by the regular knobs here, the push buttons, the switches. It also gives you the possibility to control it by the relays. If your original controller has already the relays in it, you can do it by the relays. Then for rotor AC, which is very interesting, that is selected if you want to use the ramp up feature. You need to select even the rotor AC here in the screen. And then the last one is rotor CC, which actually stands for DC. So for DC motors, you need to check the rotor CC. Okay, what's next? Then the graphics. I have the sphere already here, so you see the clock. But you can also see it as a meter. A lot of older antenna rotor controllers have the well-known meter. What else do we have? The graphics. We have a numbering. There are guys who would like to see a number, especially for guys who have visual problems. It might be very interesting to use this one. And then the last one is also a clock, but it's not an arrow, but it is, yeah, well, it is an arrow, still is an arrow, but it is more like a triangle, which moves. Right then. Very interesting, just some graphics. You can select the center to north or south if you have a rotor which has the center of its range in the south. Then you you would probably have the end stops in the north and vice versa. So if you have the end stops in the south, you have to select the north. It's just something that is necessary for the software to act in a proper way. Right then, resets the parameters. You can totally reset or partial reset. And total reset, that doesn't mean that everything will be reset, but the part, more information, more settings will be reset. But it is also explained in the manual, so I won't go into detail. The tools, also very interesting. Sub-menu. You have the possibility, or you need to adjust for the software the actually supply voltage, or not the supply voltage itself, but the voltage which is on the board measured and you can correct it here under this button. It allows you to select between 5.2 and 4.8 volts, so in small steps. Then the speed is only applicable for the DC motors, but so in my case I don't need them. Sound, IR, encoder and joystick. It also, besides an encoder, it also supports the joystick. The small joysticks, well known amongst the Arduino guys, is used to control the rotor for azimuth and elevation, so up, down, and left, right. I don't use it. I prefer to use an encoder because I'm only using it for azimuth. So, but you can select those buttons, select yes or no, and go ahead with that. Then tools. The last one is to select RS232 LAN or baud rate. All these kinds of things have been already configured, so I won't get into details. Right then, these are the most important I would like to show you. And then, of course, how it can be controlled. Let's go back and change to sphere 1 because it's more clear than for me than probably for you. Then I can choose whether I want to control with the push buttons. So the antenna is actually turning. You can't see it now. The antenna is outside, of course.
2, 4, 4.
So the direction is announced when it reaches its destination, and of course backward.
2, 2, 0.
Right. Next is just dragging the needle to a certain place, and as soon as you release the touchscreen, you will see that the antenna will turn in that direction.
8, 1.
But I also can touch the screen. Just simple touch it, and you see the antenna will move in that direction and stops when it reaches its destination. And by the way, it will ramp up and ramp down in my
2,
case
4,
5
9.
degrees. The first 5 degrees and the last 5 degrees, it will, the first 5 degrees, of course, the start from the start, it will gently move to the maximum speed, and it will slow down just 5 degrees before it reaches its final destination. Okay, let's go ahead. Then I also can use the encoder, and now the antenna will turn again.
2, 1, 2.
Okay, so it reaches its destination. These are the ways you can control it directly from the controller itself. But of course, and I don't need an IR remote control, but you can also use an IR remote controller. So and those are also the very cheap ones that can be bought on AliExpress or whatsoever. What you see is that you see here that the actually heading is also displayed in the screen. But if what happens? Watch what happens if I move to a place where it goes through this this little window here where the actual number is, or the degrees. You see that it moves to the lower part of the clock. So
3, 2, 5.
Very nice, isn't it? Well, what's next then? Okay, I won't show you the LAN and the Android version, but you can control it also over Android. The only thing is that if you want to control it over Android, you have to disconnect the screen. I don't know. Well, there is an option probably that we will be able to get it done, that you don't have to remove the display. But if you want to start very simple with just controlling your rotor via the Android app, you don't need the screen. You only need the Arduino Mega 2560, and of course some interfacing. But it is these interfaces are very small, and well, don't cost much, so it's very affordable. For the LAN version, for LAN application, you can just leave it the way it is now, and also use it by LAN. So I will show that in the next video. Thank you for watching. This is Papa Alpha 3 Victor Oscar Sierra.